On October 17 and 18, 2017, an unusual object sped across the field of view of a large telescope perched near the summit of a volcano on the Hawaiian island of Maui. The Pan-STARRS 1 telescope was designed to survey the sky for transient events, like asteroid or comet flybys. But this was different. The object was not gravitationally bound to the Sun, or to any other celestial body. It had arrived from somewhere else. The mysterious object was the first visitor from interstellar space observed passing through the solar system. Astronomers named it One-Eye/Oumuamua, borrowing a Hawaiian word that roughly translates to messenger from afar arriving first. 2 years later, in August 2019, amateur astronomer Gennady Borisov discovered the only other known interstellar interloper, now called 2I/Borisov, using a self-built telescope at the Margot Observatory in Nakhnij, Crimea. While typical asteroids and comets in the solar system orbit the Sun, Oumuamua and Borisov are celestial nomads, spending most of their time wandering interstellar space. The existence of such interlopers in the solar system had been hypothesized, but scientists expected them to be rare. "I never thought we would see one," says astrophysicist Susanne Pfalzner of the Jülich Supercomputing Center in Germany. At least not in her lifetime. With these two discoveries, scientists now suspect that interstellar interlopers are much more common. Right now, within the orbit of Neptune alone, there could be around 10,000 Oumuamua-size interstellar objects, estimates planetary scientist David Jewett of UCLA, co-author of an overview of the current understanding of interstellar interlopers in the 2023 Annual Review of Astronomy and Astrophysics. Researchers are busy trying to answer basic questions about these alien objects, including where they come from and how they end up wandering the galaxy. Interlopers could also provide a new way to probe features of distant planetary systems. But first, astronomers need to find more of them. "We're a little behind at the moment," Jewett says. "But we expect to see more." Alien origins. At least since the beginning of the 18th century, astronomers have considered the possibility that interstellar objects exist. More recently, computer models have shown that the solar system sent its own population of smaller bodies into the voids of interstellar space long ago, due to gravitational interactions with the giant planets. Scientists expected most interlopers to be exocomets, composed of icy materials. Borisov fit this profile. It had a tail made of gases and dust created by ices that evaporated during its close passage to the Sun. This suggests that it originated in the outer region of a planetary system where temperatures were cold enough for gases like carbon monoxide to have frozen into its rocks. At some point, something tossed Borisov, roughly a kilometer across, out of its system. One potential culprit is a stellar flyby. The gravity of a passing star can eject smaller bodies, known as planetesimals, from the outer reaches of a system, according to a recent study led by Pfalzner. A giant planet could also eject an object from the outer regions of a planetary system if an asteroid or comet gets close enough for the planet's gravitational tug to speed up the smaller body enough for it to escape its star's hold. Close approaches can also happen when planets migrate across their planetary systems, as Neptune is thought to have done in the early solar system. Oumuamua, on the other hand, is not what scientists expected. Observations suggest it is quite elongated, perhaps 240 meters long and as narrow as 40 meters. And unlike Borisov, it didn't show any gas or dust activity, raising the possibility that it originated closer to its star where it was too warm for ices to form. If this was the case, a stellar flyby or giant planet probably would not have been able to pull the object out of its system. Instead, it may have been ejected during the death throes of its star. Pulses of gas from a dying star could push planets and planetesimals outward, destabilizing their orbits enough to send some of them flying into interstellar space. It's possible, however, that Oumuamua did form in the cold outer reaches of its system and, as it neared the Sun, developed a gas tail that was not detected by telescopes. One clue is that the object sped up more than would be expected from the gravity of the solar system alone. A recent study suggests that such a boost could have come from small amounts of hydrogen outgassing that the telescopes didn't detect. Several asteroids in our solar system may have gotten a similar boost from outgassing of water vapor, according to another study. Future observations by the James Webb Space Telescope and by the JAXA Hayabusa 2 extended mission, which will rendezvous with one of these solar system asteroids, known as dark comets, in 2031, may detect low levels of outgassing. We'll have to wait and see, but they could be analogues of Oumuamua, says planetary scientist Daryl Seligman of Cornell University, co-author with Jewett of the Review of Interstellar Interlopers. Searching for nomads. More data from more interlopers may help resolve some of these questions. In order to gather these data, scientists will need better odds of detecting the objects when they pass through the solar system. If Pan-STARRS 1 didn't observe where we did that particular night, it's likely that Oumuamua would never have been found, says astronomer Robert Wyrick, formerly of the University of Hawaii, who discovered the interloper in the telescope's data. The upcoming Legacy Survey of Space and Time at the Vera C. Rubin Observatory is expected to increase astronomers' chances of finding these fast movers. Beginning as soon as 2025, the observatory's telescope will image the entire visible southern sky every few nights, and its primary mirror has a diameter nearly 7 meters larger than Pan-STARRS 1, enabling it to see fainter objects farther away. Once interlopers are detected, ground and space-based telescopes will image them to try to determine what they are made of. And if a reachable target is discovered, the European Space Agency and the Japan Aerospace Exploration Agency's Comet Interceptor, slated to launch in 2029, could be redirected to image the visitor up close. Eventually, astronomers hope to build a catalog of interstellar objects similar to the inventory of exoplanets, which has grown to over 5,500 entries since the first discovery in 1992. That future inventory could help researchers answer the long-standing question of how typical Earth and the solar system are. The compositions of a large sample of interstellar objects could yield clues about the makeup of objects in exoplanetary systems, including ones that might support life. Planetesimals are the building blocks of exoplanets, says astronomer Meredith Hughes of Wesleyan University in Middletown, Connecticut. This means they can provide information about the diversity of environments, including ones that could be habitable. Now, Oumuamua is beyond the orbit of Neptune, and Comet Borisov is almost as far. They will continue their journey back into interstellar space, where it's anyone's guess what will happen next. Perhaps they will spend an eternity wandering the vast voids of space, or maybe they will be captured by a star. Or they could collapse into a disk of evolving gas and dust in a new planetary system and begin their journeys all over again. Astronomers estimate there could be more interstellar objects in the Milky Way than stars in the observable universe. Finding more of them will offer a new way to probe the mysteries of the cosmos. The really cool thing, Falsner says, is that interstellar objects come to us.